Hi everyone, my name is M.2 and today we will talk about MemryX board. In my opinion, it's pretty interesting board, but before we will start, I want to make a small disclaimer. This board was provided to me for free. Also, they proposed to answer my questions, so I used this opportunity and asked a little more for this video, but I asked them this question only after I researched this board myself. And in this video, to be unbiased, I just want to mention this for you to decide. So, what is MemryX board? It's actually M.2 accelerator. Right now it's connected to my PC, so just the box. And it's like one of competitors to pretty popular accelerators like INT8, which I already had on my channel, like Accelera, which also was on my channel, and maybe I will do another video about it in a few months, like DeepX, which I didn't test for now, and Sima AI, which I had interview with, but I also didn't test it. So it's like AI accelerators which can help you to run your neural networks. What is the main difference with all this big family of M.2 AI accelerators? Actually, in my opinion, for this one board, the main difference is it's super nice and convenient to work with. The board is super impressive in terms of usability. It's convenient from how to inference your code, how to export your models. It's convenient from the side that it's fully open source board, which is pretty rare, and how to set up it in your system. But let's go step by step. How I tested this board? I tested it only with my x64 PC. I tested it with Windows and Linux Ubuntu. And for each system, setup of this board was like less than 10 minutes. I haven't tried it on ARM, but it should work according to the documentation, and basically it's the same as Ubuntu. And docs also mentioned potential support of RISC-V. I didn't test it, but maybe, I don't know. I can guarantee that it will work for RISC-V. Overall, all the installation is super fast and nice. So, working with this board. From developer perspective, like researcher, ML researcher, the most convenient way, of course, is Python, and it's fully support Python, and the inference code is super regular. You can run it in Python with like just direct inference, super classic. But it's not only this way to use this board, because first of all, as you know, for such boards, if you send in some image to process on such board, there will be some latency. And of course, almost all of such boards, at least like Halo, Accelera, all of them have the second way where you like sending your images and receiving your results in parallel. MemryX also has this opportunity, and it's also work with Python. A little bit more complex code, of course, so you need to manage a few streams, but it's possible. Also, there is a C++ way to infer in both ways, but I didn't test. With Python, you also can simulate your inference or your PC. You can prepare your models and you can export it. But actually, the most convenient way to export is just using their direct libraries for such export. They export tools has ONNX support, and it supports almost all variety of TensorFlow models like TensorFlow, TensorFlow Lite, Keras. They also mentioned that PyTorch support is planned, but for now it's just like ONNX is the most convenient way, of course. Everything is pretty regular, no differences here. It's more convenient than Celera, where inference is more complicated. The expert, in my opinion, is a little bit more convenient in Haleb, and I will touch this point a little bit later when we will touch about INT8 and FP16 support. Here is everything is straightforward. In my opinion, maybe Intel NPU is the closest competitor in simplicity and variety of all this support. Model Zoo. MemryX took a pragmatic approach here. They just exported all models from Pinto Model Zoo, and they highlighted which model will work with their board, which will be the inference speed, and so on. Of course, if you will go through Pinto Model Zoo, you will find that it's not all models work here. Also, you may find some models that are a little bit strange, and maybe they are not fully exported, for example, like with this stereo depth estimation model, but they promise that they will support it in the future. On other models that I tested, I downloaded them, everything was working. The main difference with such approach to your Model Zoo, it's not officially maintained, they have not guaranteed that everything is working, but you can take any model and test it if it will run. Also, they have around 10 supported end-to-end samples in the example directory, so you just can check how to set up your inference, how to work with different streams, and so on. In my opinion, documentation here, it's fantastic, which I will also mention a little bit later. Let's touch the most interesting part of this board. In my opinion, it's the ideology of INT8 and FP16. Usually, all previous boards for computer vision I tested, they were either INT8, either FP16, either you can choose which one mod you will inference your model in. And actually, INT8 quantization, it's pretty problematic because sometimes your model will not work after such quantization, and it's hard to fix this. For some models, it's almost impossible. For some models, you need to infer specific layers on your GPU to maintain, or on your CPU to maintain high level of accuracy. On the other hand, when you infer your model in FP16, it will be more expensive for hardware developers to develop such boards. It will be slower, and there are some differences with this approach. So a lot of vendors who want to give your maximum speed on the smallest amount of money, they are not going this way. But actually, there is another way, which used pretty often in LLMs. And this way, it's INT8 weight and FP16 activations. With this approach, you don't need to quantize your weight. You can work with your weight direct, and the model accuracy, it will be lower than FP16, full FP16 inference, but it will be much higher than out-of-the-box INT8 inference, and you don't need to quantize. It's also possible to run some additional features to improve your FP16 accuracy. For example, you can infer few separate layers, usually it's output layers, on your in FP16, and it will give you more accuracy. But actually, it's the first board for computer vision where I see such approach. What can give you such approach? Your model will be smaller, same as your INT8 model. You don't need quantization process, so it will your development much easier and much more native. And of course, it gives your cheaper devices with higher speed. And in my opinion, it's a pretty nice solution. The only difference from direct INT8 inference, actually, there are two differences. One difference, it will be not as fast as fully INT8 inference. And the second, of course, it will require a little bit more complex board. And of course, in situation when you need some iteration on your model when you want to change your models in future, this approach may be one of the best. Of course, like direct FP16 also good, but this is pretty nice competitor. It can give you additional speed, smaller models, and so on. So in my opinion, this is a killer feature of this board. Let's mention a few interesting parts of this board. First of all, quantization. The second, it's super nice documentation. Actually, there are a few approaches how you're doing your documentation. For example, some vendors like NXP, they creating a lot of documentation. You can find almost everything in such documentation, but it's really hard to find something. Usually it's like a few different manuals in different places. Sometimes they are not very actual and code base is a little bit different. So it's super hard to find anything. The other approach, when you have in documentation just few super basic things, and usually it's not enough when you go in deeper. In my opinion, documentation for MemryX, it's one of the best documentation because it's give you like super easy and fast way how to do everything. And then you have like direct links in the same documentation, how you can go deeper and deeper and deeper. And they think a lot about the structure. And in my opinion, just for me, it was the easiest documentation I read in the last few years. Again, maybe like Intel NPU is also pretty simple and straightforward, but maybe it's because I previously worked with Intel. But like Intel documentation also seemed to me one of the best. Of course, there are some downsides. First of all, I think I should start from the speed. And from the speed perspective, this model is not the fastest. You have Halo, even Halo 8 is a little bit faster, like depending on the neural network, but from 20 to 50%, I think. Accelerator is faster. Of course, this board will be faster than Halo 8L, but it will be cheaper on the other hand, which is also nice. I was thinking to do different model comparison in this video, but I decided that maybe you can just go, for example, here it's all the models, all the VPS for such board. Also, you can check them for Halo and for Accelerator, they also publish in them. So I don't think if it's needed to compare all this speed. I took a few models, I checked, speed is pretty close to official documentation. So in my opinion, it's okay. What I also want to mention that they also publish this latency for two different modes, like one is in parallel inference and the second in direct inference, which is pretty nice. And in my opinion, it's also pretty important values. And sometimes, for example, Halo is not publishing such values. It's pretty nice in my opinion. Second limitation, downsides, it's memory constraints, which of course will affect that not all neural network will work. If you will check architecture of this board, specifically this M.2 unit consists from 4 independent accelerators which are connected with each other. Each accelerator has around 10 megabytes memory directly on the crystal, and altogether they have 40 megabytes of memory. Of course, for some models you can like load memory in parallel, there are some cheats, but of course when you need like a big layer or big multiplication simultaneously in memory, and of course you will have this often in transformers, this will not work. Actually, this problem is the same problem that Halo has, the same problem a lot of vendors have. It will limit you from running big neural networks. Of course, it will limit you from run transformers. Actually, speaking of LLMs and VLMs, I think only one neural network you can, or 2 neural networks you can run here. And of course, it's like some limitation. There are few like models with features like with classic convolutional as input with maybe small transformer on top, but I didn't go deeper in them. I tested a few models that's important for me, usually, for example, like stereo depth estimation. And to be clear, right now there is no NPU accelerator which can run stereo depth estimation efficiently. And this one is also can't do this. Also, they promised that there will be some PSNet, it's something like stereo net depth estimation network, which is pretty old. They promised that it will run in that it will be in their examples in the future. Actually, it's the only stereo depth estimation network that a lot of vendors use it. For example, Halo has it, RX FDK-A5, which was recently on my channel, used it, and Huawei can run it, Intel can run it. So it's pretty popular network for NPUs, but it's super old, like 7 years old, and it's provide pretty bad depth estimation. But from all modern depth estimation network, MemryX doesn't support them. The second limitation, of course, it's all LLMs, VLMs. In my opinion, it's okay for a lot of application actually, and a lot of application will not require this, but in near future, maybe few year, all these LLMs and VLMs, they will be standard for a lot of application. And for example, maybe even some high-level agents that collect prediction from different networks. So in my opinion, in the future, of course, you will need it, but right now, for most of application, it's not crucial. Again, transformers networks, and it's some networks for feature estimation, like CLEAP, SIGLEAP, and all other big pre-trained networks that can efficiently extract some features that you can monitor, that you can check your system, and so on. There are a few neural networks with one-shot learning, but they are for detection. It's some version of YOLO-T, if I remember correctly. They have them in the board. So it's pretty nice, but of course it's not the whole variety of the modern network, but just few specialized. So they definitely can help in some situation, but in my opinion, more important to have some more general models. So again, in my opinion, all this limitation, it's okay. A lot of boards have them. They limiting you from some big model inference, maybe some robotics, some automotive like driving. But in general, for cameras, for maybe some drones, for some inferencing in cars, but for simpler tasks like sleepiness estimation and so on, this board is great. Another downsides, in my opinion, it's pretty small community right now. It is what it is, and of course when you have super big community around the board, you have a lot of issues, pull requests. So for example, when I was working with this board, I found a few problems in their repositories. I fixed all of them with one simple change in the code, and it was much better than, for example, some rock chip. But when you have a community, usually you can easily find such solution in issues. It's much easier to understand what is happening. And of course, from community perspective, today's leaders, it's NVIDIA, Intel, Halo, Rockchip, but MemryX, it's not a leader here. But because they have nice documentation, nice organization, in my opinion, it's okay for now. Maybe in future. So, what is my final verdict here? The board, in my opinion, is great. The board is definitely one of the best board to start your experience with accelerators. Maybe if you want to run your inference on NPU, maybe one of the 2 or 3 best approaches today, because the other one, it's in my opinion Rockchip. The third one is Intel, but Intel, it's not the full NPU experience, it's some regular CPU. So it's one of the best board, better from this simplicity than Halo, better from this INT8 model expert, but of course it's not the fastest board on the market. not as the best model in terms how to run every model, but it's really pretty powerful board with a nice architecture around, open source stack around. They even have open source their drivers, which is super cool. It's, I don't know, like which board else. Maybe some new ARM boards did this, but in my opinion, like MemryX, one of the best from this, how it's open, how it's support everything, but of course limitations. So thank you for watching. I hope this video helped you, and I will meet you in the next one. Bye.